Bitlismen equips students, professors and scientists for next-generation industrial revolution. We prepare them for Industry 4. My name is Gevorg, and today I will demonstrate the solar power generation trainer, a family member of our PowerLabs ecosystem. The aim of the trainer is to study the conversion of solar energy into electrical energy. It introduces the main principles of solar power generation and its characteristics. Now let me demonstrate the trainer setup. The trainer consists of the software with experiments, mounting frame where students can mount the modules related to each lab, and the PV panel module, which consists of two main parts. The sun simulator with regulated daytime trajectory and year-time trajectory and light intensity. The second part is the PV panel itself with the solar irradiation sensor and the solar tracker sensor, and DC-DC transformer to connect the PV panel to the grid inverter. Both X and Y angles of the PV panel can be controlled either manually or programmatically. Additionally, it is possible to control it automatically with the solar tracker algorithm. Now let's pass to the demonstration of some functions of the trainer. First, let's have a look at the software. It has a bunch of experiments. I will choose one of them and run the system. At the beginning, the software requests to implement the required connections on the trainer. As you see, the software has a self-descriptive and user-friendly interface. It allows to monitor both mechanical and electrical parameters such as solar irradiance, PV panel voltage, current, etc. Now let's implement the appropriate connections and run the system. Hope you enjoyed the video. For more information, visit our website at bitlismen.com. First part is the infrastructure for emulating the wind speed. It consists of a variable frequency drive, motor with a V-belt drive, and a fan with RPM sensor. The second part is the wind tunnel itself with a wind speed sensor. And the third part is the wind generator with its voltage regulator. Now let's pass to the demonstration of some functions of the trainer. First, let's have a look at the software. It includes 5 experiments. I will choose one of them and run the system. At the beginning, the software requests to implement the required connections on the trainer. Now let's implement the appropriate connections and run the system. As you see, the software has a self-descriptive and user-friendly interface. It allows to monitor both mechanical and electrical parameters such as wind speed, rotation speed of the generator and the fan, generated voltage, current consumption. Moreover, it provides deep analysis of power parameters such as sine waves, voltage and current RMS, frequency, active, reactive and apparent power, power factor and vector diagram. Hope you enjoyed the video. For more information, visit our website, subscribe to our YouTube channel to get more videos of our products. There's a lot yet to come. The first part is the infrastructure for emulating the head of hydropower station, water pressure and flow. It consists of water tank, pump, and the pipeline with valves and sensors. The second part is the hydropower turbine with its governor, which is the valve. The third part is the generator with the excitation control and the V-belt drive for 50 and 60 Hz options. Now let's pass to the demonstration of some functions of the trainer. The aim of this combined trainer is to study the basics of microgrid, where you have three power sources: the rechargeable battery, the wind power generator, and the PV panel. The trainer introduces the main principles of power flow within a microgrid, with multiple renewable energy generation sources and the battery as a backup power source. Now let me demonstrate this trainer setup. The trainer consists of a software with experiments, the mounting frame where students can mount the modules for each lab, the wind generator module, the PV panel module, and the small distribution substation simulated as a single transformer, and the load. In order to have a synchronous operation between these two AC and DC generation sources, we will use a grid-tie inverter to get the AC microgrid. Now let's pass to the demonstration of some functions of the trainer. First, let's have a look at the software. I will choose the synchronous operation of wind and solar generation sources. Now let's implement the appropriate connections. Let's run the system. Hope you enjoyed the video. Motor generator module, which consists of two main parts. The asynchronous motor, which can be controlled with a VFD module to simulate different mechanical energy. The second part is the synchronous generator with an excitation module and a tachometer. The module allows to manually change the excitation current and generate different voltages and frequencies within 50 to 60 Hz. Now let's pass to the demonstration of some functions of the trainer. First, let's have a look at the software. It has a bunch of experiments. I will choose the lab when the generator will operate in parallel with the network. At the beginning, the software requests to implement the required connections on the trainer. As you see, the software has very cozy and nice user interface. It allows to monitor both mechanical and electrical parameters such as rotation speed of the generator, generated voltage and current, etc. Now let's implement the appropriate connections and run the system. I will demonstrate the manual synchronization of the generator with the network. First, we turn on the VFD module. And after that, we are allowed to apply the excitation current to the generator. And now we have to adjust the generator frequency with the grid frequency. Now I have adjusted the grid frequency with the generator frequency and also the voltages of the generator and the network. Now we can start the manual synchronization. And here we have to wait until the voltage difference between the grid and the generator reaches 0. The system will not allow me to connect the generator to the grid because the voltage difference is not 0. And we have to wait until it reaches 0. And now, as you can see, the generator is connected to the grid. Now we can apply additional power to the generator. After this, we can test the same with an automatic mode of synchronization. As you could see, the system automatically connected to the grid. Overhead line modules, which simulate a model of a real transmission lines, they allow as well to simulate line-to-earth and line-to-line short circuits. There are also step-up and step-down transformer in order to simulate the whole transmission system. Now let's pass to the demonstration of some functions of the trainer. First, let's have a look at the software. I will choose the lab where I will demonstrate the protection of short circuits. Now let's implement the appropriate connections. Now let's run the system. Now I will demonstrate the protection algorithms for earth short circuit and line-to-line short circuits. First, I will demonstrate the earth short circuit. For that, I will turn on the switchgear, which will power on the whole transmission line. Then I will go to the protection settings. Here I have already predefined some settings, and I will send those settings to the relay. Now I can close this and then simulate the short circuit on the overhead line module. Now, as you could see, the protection system detected the short circuit and waited for the time defined by the user, and the protection switched off the switchgear and powered off the whole transmission line. Now we can open the monitoring window and see which level of the protection was tripped and what was the timer value, and also the measured residual current. Here we can also reset the protection again and start again. Now I will demonstrate the line-to-line short circuit. For that, I will turn on the switchgear again. Then from the protection settings, I will change the settings and send to relay. Here from the protection monitoring window, we can monitor the protection. And now on the overhead line module, we will simulate the short circuit. As you could see, the system detected the short circuit and tripped it after the predefined time. The trainer has busbar module, circuit breaker and ATS modules. The busbar module simulates a model of a real busbar system with two disconnectors. It allows to investigate different switching algorithms in the distribution substation. Now let's pass to the demonstration of some functions of the trainer. First, let's have a look at the software. I will choose the lab where I will demonstrate the two switching algorithms. First, by manually controlling the switch gears and automatically using the ATS module. Now let's implement the appropriate connections. I will demonstrate the manual switching mode, which consists of 3 switch gears, switchgear number 5.1, 5.2 and 5.3. And the 5.1 and 5.2 cannot be switched at the same time simultaneously, and the system will handle that. For example, when I switch on the 5.1, the system will not allow me to switch on the 5.2. But when I turn off the 5.1, I will be able to turn on the 5.2. And turning on the 5.3, I will supply the load. As you can see here, the loads and the voltages. The reason of not allowing to connect the switchgear 5.1 and 5.2 simultaneously is just to protect of having the main supply connected to the alternative one, in order to avoid any short circuits. Now we can demonstrate the switching in automatic mode using the ATS, Automatic Transfer Switch module. For that, I will turn off the 5.2, I will turn on the 5.1, and I will put the ATS in auto mode. And here, with turning off the 5.3, we will simulate the disconnection of the grid, and the ATS will automatically switch to the alternative source. Here you could see that the system detected that the grid was disconnected and switched, the ATS switched it to the alternative source. The aim of the trainer is to study the basics of power protection. It introduces the main principles of electromechanical protection relays and its characteristics. The trainer consists of the software with experiments, mounting frame where students can mount all the necessary components related to each lab, and the DC generator module, which consists of three main parts: an AC motor, a DC synchronous generator, and the DC power source, which acts as an excitation source for the generator. Now let's pass to the demonstration of some functions of the trainer. First, let's have a look at the software. It has a bunch of experiments. I will choose one of them and run the system. Now let's implement the appropriate connections and run the system. As you see, the software has a self-descriptive and user-friendly interface. It allows to monitor both mechanical and electrical parameters such as relay coil voltage and current consumption, contact switching time, generator voltage and current. Hope you enjoyed the video. For more information, visit our website, subscribe to our YouTube channel to check our other products. Thanks for watching and stay tuned.